on this computer. Is it recording?
Yep.
All right. All right. So this is part 4, right, of episode 10?
Yeah.
Cool. All right. So we'll start in 3 or 5, 4. And we're back. This is going to be part 4 of episode 10 of The Road to Code.
The road to code, baby.
So in between episodes, Jonathan went out and designed a logo.
Yeah, we got a new logo now.
We got a logo. Not only did we get a podcast name after the first episode, but now we got a logo. It only took us 10 episodes.
Well, it technically is 6 episodes in, because once they come out, it's 6 episodes, but we're filming it on our 10th episode yet.
You want to give everybody a glimpse of what that logo looks like?
Bring it up. And I designed this myself, kind of. I had some help from a graphic designer, I guess you could call him. But this is what I came up with.
Show it to us.
The road to code.
Look at that.
We have a logo.
It's a pretty sexy looking logo there, if you ask me.
It looks techie, has some of the little code thingies, the less than and greater than symbols, and in between the road. So that's pretty much what I wanted.
And then you have like that, that spatial, like mapping of the astronomy type of background.
Yeah.
Which, you know, it could be considered like mapping of how electrons travel and stuff.
Yeah. How everything's connected.
Yeah. And then the Road to Code podcast. I like it. I like the contrast colors and everything.
The text, I like how the text of the Road to Code, I like it too.
Yeah. Kind of looks like looks a little bit like oh man, what is the Back to the Future type of title?
The text on the Road to Code.
Yep. Cool. Futuristic. So I think what's the next step? Putting it on t-shirts and cups.
Yeah, we'll have some new merch pretty soon. That'll be coming out.
Yeah. Keep you guys posted on all that stuff. That'd be cool. All right, so excuse me. So this is part 4 of episode 10. We definitely have extended this one to its limit. And let me share my screen on what we've been working on. So I'm sure everybody remembers this diagram. This is the console application that Jonathan created. And within the console application, we created our connection, we created our command, and we executed one of these, a reader, non-query, or I don't think we executed scalar, but that's available. And from these, we got some kind of result, whether we got a reader, an integer, or some kind of value. And so this connection and command, they communicate with SQL Server using Transact SQL, which is a programming language for SQL Server. We call the store procedures, and it in turn produces some tabular data. And this fancy word tabular just means it's a table. So a table, if you can imagine Excel, if you've ever worked with Excel or something similar like Google Sheets, it's just rows and columns, nothing fancy. It's just more of a fancy word. And so we receive that through the reader, and then we iterate through each row and calling out each column and pulling the data from each column and displaying it on the screen. And so that's kind of essentially what we've been doing, right? And so this particular model is an old architecture called client server. So the client is a console application. The server is the database server. So the client would contact the server, it would grab data and it would crunch it. But this application as a whole is, again, an old, legacy term for this is called a monolithic application. So this mono means one,
Mm-hmm.
and lithic, you know what? I don't even know what lithic stands for. Let's go see what lithic stands for.
You could lift thick. No, just kidding.
Monolithic. What is it? Definition. Formed of a single large block of stone. Okay, so I guess lithic is a stone? Nature relating to stone. Okay, that makes total sense to me. So what happens is in programming, there's a lot of references. There's like references to biblical, there's references to like earthy, there's references to the astronomy, there's references to the planets. It's like there's all these references everywhere.
Mm-hmm.
And so I guess the reason they called it monolithic is because when you create an application like this, it is very hard to break it apart. In fact, we're going to go through the pain points of breaking this apart, and you're going to realize how much work it takes to break an application apart. And so our goal is to take this monolithic application and turn it into an application that has several layers. So essentially, your console application is going to be just a console application, and it's going to use a layer called repository. It's a pattern. It's a common pattern that's used. And so this repository layer is what's going to be the glue between your client or your console and your data. So we're going to separate. You're going to see our methods are going to go from like 3 to 4 methods. I think we have like a handful of methods right now, right? But they're huge, they're long, it's like they go beyond the screen, and that's not good. They become really hard to read. You have to sit there and scroll up and down. There's a reason why you want to keep the methods small. And I mean, if you think of the history of certain patterns that we've established, right? The mind has a certain limitation. And so beyond seven of anything, the mind kind of just loses, right? This is why you have a phone number with only 7 digits. It's really easy to memorize 7 digits. You have addresses with, 3 to 5 numbers. So they're easy to memorize those numbers. And then you have the name of the street. So it's a lot easier to break stuff up. You could never memorize an IP address. So you can memorize a word, right? Even though the word can have, more than 7 letters, it's just one word that you got to memorize. Mm-hmm. And then you just know that it's .com, .net, whatever it is the case, to get to that website. Because if you had to memorize the address, the IP address, you would never memorize it. They're too difficult. So creating our application in these layers makes it so that we have a lot more methods, but every single one of our methods is like a bite-sized chunk of code that's really easily digestible. We can look at that code, and if we need to go into the next layer, it's a lot easier to follow like smaller chunks of code than to have these long methods, right? Mm-hmm. So let's go ahead and have you share your screen, Jonathan, and open up that console application. Man, you're moving quick now. You need to open up Visual Studio too. Look at you, operating like a pro.
Yeah.
And then let's go into Visual Studio and open up that console application. Is it significant? I think it's significant.
Yeah.
And so yeah, let's go to Solution Explorer when it comes up. So yep. Excellent. And then you can unpin those properties on the lower right. You can go ahead and unpin that. It gives a little bit more real estate on that. All right, so let's go to the top of this program. We have one program, and go to the top. And this main program is about 30 lines of code, maybe 25 lines of code, which is quite big. It really should be a handful. You know, there shouldn't be very many.
Okay.
I'll give you an example of what code. Go ahead and stop sharing, and I'll share my screen really quick. Let me go to, let's see. I guess I can go to, I can go to GitHub. And let's look at Conduit. Conduit is an open source application, and it's publicly available. And I'm going to go into, this follows the same pattern. I got repositories and I have data, and then this is our API. So this API project is equivalent to like a browser, maybe another application. You know, this is kind of where it's at, right? And then here's the data. The data, if we go look at the data project, that kind of represents this project here. And then we have the repositories. And so if we go look at our API and we go into the controllers, and I don't know, pick one at random. Go ahead. I'll let you pick just so that you can see how small these methods are.
All right. Tags.
Tags. This is the controller. This is the tags. Let's look at it in a raw form. Actually, pick another one. That one's not done yet. Okay. Oh, I lost it. Where's it at?
Closed it.
Conduit, API, controllers. Yeah, anything but tags.
All right.
Something that you would think is like, man, this one's going to be big. And it's not the weather forecast. The weather forecast is a standard API that comes with the solution.
Users controller.
Users.
I figured it has an S in it. That means it must have multiple in there.
It must have multiple. So this is one method right here. And it's about 20 to 30 is 10 plus 7 is 17. And 1, 2, 3, 4, 5, 6, 7, 8. Well, we can't count these two. So it's 1, 2, 3, 4, 5, 6 are just curly braces. So really it's 11 lines of code. And if you take away the try and the catch, it really comes down to just 2 lines of code here. Because this is where all the heavy lifting is being done. And these are just what they call boilerplate code. So we're going to try the happy path. And if we have a login failed exception, then we'll go ahead and return this. You know, we'll log the warning. Anything else, we'll go ahead and just log the error. So this is a rarity, this exception, where we're going to have to log the error. We're hoping that this is an extreme case, and chances are we'll never hit that unless our database goes down or something. The warning, we might hit it a little bit more often. People may fat finger their password, mistype their email, whatever the case is. But this is it, 2 lines of code. So this calls this login async method in the account repo. So this is a repository. So let's go back and look at the repositories. We'll go into the repositories and we'll follow the account repository because that's where it was calling it. And if we go through here we go. We have a total of 31 through 44. That's what, about 13 lines of code?
Yeah.
Here is 5 lines of code. Here is another 5 lines of code. Oh, this one's pretty big. This one is 10, 11, 12 lines of code. 10 if you don't count the curly braces. This one's pretty big. 84 to 94 is 10. So about 15 lines of code. About 11 lines of code. About 1, 2, 3, 4, 5 lines of code. Where is our login? Here's our login right here. Our login is pretty big actually, but this is really one line of code because there's your semicolon.
Yeah.
So this is really one line of code. So that's 1, 2, 3, 4, 5, 6, 7, 8 lines of code. That's the whole login right there. So you can see where breaking it up into different projects across, it becomes a little bit more manageable, right? Because we saw, if we go back to the API and we go to users, and we go to the login, this is essentially what we got. We have a login request and we log in the user. And if we go back to Conduit, repositories, account, repository, and we go down to the login, here it is. We're essentially calling the context. We're calling the account where the email is equal to the login email. And we're going to include the person information. And we grab the first record or a null if it doesn't exist. And we do it in an asynchronous manner. And if the account is null, then we throw a login failed exception. Or if the password is incorrect, we throw in a login fail. So these two are just kind of exceptional behavior, either a wrong email or a wrong password. We create the account and we create the token to log in the user, and we return the user, and it goes back to the whatever client called it. So it's pretty easy to follow, you know, when you have smaller methods rather than having a big, and believe it or not, at one point, the way that we coded that console application is really the way things were done on a normal basis. And as the software field began to grow, we began to learn, and we're like, hey, we should be breaking these things up into smaller pieces. So you actually walk in to learning software based on a new industry standard that, you know, it's better practice is what I guess what I'm trying to say. So the way I showed you is a great way just to learn the commands, but it's definitely not the way to go and create applications that we need to go and create. So go ahead and share your screen again. And we'll go ahead and create 2 projects. So you're going to right click on that solution. We're going to create 2 projects. Actually on the solution. Cancel. Oh. Yeah, right click on the solution and add a new project. And this project is going to be a class. So you already have it over on your left. So if you just go and double click on that class. And then, so your name is going to be significant dot, it's with the C.
Oh.
Yeah, dot, and it's going to be data, uppercase D. Yeah, go ahead and create that. Excellent. And then we're going to add a second one. It'll be significant.repositories. Same thing. It'll be a class project or a class library. Actually, sorry, not class library. It's going to be repository. Not to be confused with suppositories, please. I wonder if anybody ever listens to those dad jokes I throw in there once in a while. All right. Excellent. So let's go ahead and let's go into data and right click on that. Oh no, you don't have to. You can close this tab. You don't need this one. Let's go ahead and rename that class 1. So right click on class 1 over on the right side, right click on it and rename it. And let's call this, what is the name of the table that we're dealing with?
We have.
Is it person or?
Person. Yeah, it's person.
It's person, right?
Oh no, I think the table is called people.
People?
People or person.
Let's go check program really quick. Let's go see what it is that we're accessing. Go to program. And let's go down to one of your, so this is, oh, it's birth dates.
Oh.
Okay. So we're going to rename that class to birth dates because this is going to be specific to the birth dates. Yeah. Okay, so you see that where it says delete record on line 48 to 63?
Yeah.
Let's copy the body from line 50 to line 63. And then go ahead and go to birth dates. And in here, we're going to create a public, it's lowercase, public, and let's go ahead and do a void for now. We're not going to return anything. We'll change it after because we will need to return something. And we're going to call it delete. And then open close parenthesis and then open close curly braces. And then actually the curly braces go outside of the outside the parentheses. Yeah. Go ahead and press enter and go ahead and paste that body in there. Excellent. So in here, I think we have one too many curly brace. Oh no, you just got to fix it. You could do Control KD and it would have fixed it. Oh. All right, so let's go ahead and fix our squiggly marks. You remember how to do that?
Right here.
Yeah. And so this one here, we're going to need to, we're going to need to include a library. Okay. So let's go look. You see on the significant console app and where it says dependencies, go ahead and expand that on the console app.
Oh. Where are we at?
Yeah, so you got significant data, and then right above significant data, you have the significant console app. Yeah. And let's look at packages. So this one includes a package called system.data.sql. So we need to include that same package into the data. So let's go ahead and right click on the significant data project.
Oh.
Yeah, on the significant data project.
Hold on, you cut out right here.
No. And the significant data project.
Okay.
Yeah, right click on that. And we're gonna go to manage Nuget packages. So Nuget packages, that's something new for you, isn't it, Jonathan?
Yeah. What's a Nuget?
So let's talk briefly about Nuget. Nuget, there's this concept called, or there's an acronym, I should say, called DRY. or dry concept or dry practice. I forget exactly how they use the acronym dry, but it's called don't repeat yourself. Okay, so when you don't repeat yourself, that means someone else already did the work for you. And so the connection to SQL, you don't have to write it. Somebody wrote it. The command to SQL, somebody already wrote it. You don't have to write it. So we're going to reuse some of those libraries. And Nuget is a repository of libraries that other developers have written. And so we're going to reuse those libraries. And one of the libraries is systemdata.sql client. So if you go to browse, go click on the browse and go ahead and look for, I think if you just look for SQL client, it might come up. One word altogether. Oh, there it is. Cool. It's the first one. And that's exactly the same one that you have over there, 4.82.
Mm-hmm.
Go ahead and click on the install. So what's gonna happen is gonna install that package and all its dependencies. So this is telling you this is everything that it needs.
Okay.
It needs all those packages in order to run. So you hit OK, and it's gonna install that package onto, and there's some licensing agreement. So it just means that you're gonna give them your firstborn and stuff. Microsoft. And so, what happened here? Oh, okay, yeah. I know what that is. So it's going to install all those packages onto significant data. Okay, so let's go ahead and close this tab, and let's go back to your birth dates and hover over those red squiggly lines, and let's see if it fixes it. See, now you can say using data SQL client. Go ahead and click on that first one. And that might fix them all. Oh, the command type, you have to fix the command type. We'll come up to the connection string in a moment. The connection string is something that we got to fix. System data. Okay, cool. Pretty cool?
Yeah.
We good? So let's go over to the program tab and let's go grab that connection string. So if you go all the way to the top, remember we put it up on top?
Oh, this one.
Yeah, just grab that whole thing. And then just put it right above the public void delete. In between the public class and public void. Yeah, there you go. And then let's go ahead and remove the static keyword from it. This is going to be an instance. Actually, let's replace it with private read-only string. Yeah. And then just out of practice, you're going to leave a blank line between the member and the method. So we've just created a member to the class. It's like a variable to the class.
Mm-hmm.
So, and then on line 10 is the method delete, right? So you want to leave a blank line between those two. Yeah. And so that fixes our connection string at that point.
Okay.
Pretty good?
Yeah.
All right. But now it needs a record ID. And so the thing about having this significant data project is that we want to be able to use it anywhere. And it should be self-sufficient and return the information to whoever calls it, right? But that means that it cannot query the user. It cannot ask the user, okay, what's the ID that you want me to do? So it has to receive that ID. So we're gonna let the console application deal with the user. The console is gonna grab the ID of the record that they want deleted, And the console is going to pass it down through the repository. The repository is going to pass it on to the data. And the data says like, oh yeah, he's like, give me the ID and I'll do all the work that I need to do.
Mm-hmm.
So inside the parentheses of the delete, we need to pass in a parameter. We need to say, hey, you're expecting a parameter. And that parameter is going to be an integer. So int, and then just call it record ID. And you can delete line 14. We don't need that anymore. Just exit out of there. Yeah. And then you could also get rid of line 13 because it won't be writing to the console. Our procedure is starting to look pretty simple now, isn't it?
Yeah.
So, I mean, now you understand what this method is doing. It's like, hey, I receive an integer that represents a record ID, and I go and I call a stored procedure called birthdates delete, and I pass in that record ID. I open the connection, I execute non-query because I'm not expecting any records back. And then I close that connection and I'm done. Mm-hmm. You know, it's a void, and public void means it doesn't return anything. You know what I mean?
Mm-hmm.
So that's it. We're done with refactoring this piece of code. Okay. Pretty cool.
Yeah. That was easy.
Let's go grab the next one.
Okay.
Go to program, and what's the next one after delete? Update. Yeah. Okay, cool. So let's grab the body of that record, of that method. And then let's create, let's go ahead and create a new method called public void update. Open, close, and then your curly braces, and then paste that body in there. And then we're also going to want to do, just like we did a blank line between the member or the variable at the class level and the method, we also want to put a blank line between methods, okay? So let's look at the meat and potatoes of this method, okay? Remember, this class, the data class, is not going to interact with the user. It needs to receive everything in order to perform its duty, okay? Mm-hmm. So in this case, it's going to perform an update. And one of the things that we need to do is we need to be able to create a custom object that is going to have all that information and just pass it in. Now, we can also say, hey, we're going to give you an integer record ID, a string that's a full name, a date time that's a date of birth, and a date time that's a date of death, and then a string that represents the notoriety. And we can put them all as parameters in the update method. But then the moment we decide to add another one, we're going to have to also come back and modify all the methods that chain up that command in order to update. So instead, what we'll do is, instead of modifying the signatures, all we're going to do is just modify one object. Okay. So let me share my screen. Go ahead and stop sharing for a moment.
Okay.
And we're going to expand on this right here. And what we're going to do is we're going to create another project. And this project is called Models. And so this Models project, I'm wondering if I should have, can I go sideways? Oh, you know what? Maybe I could go sideways. Yeah. There we go. Now we're talking. And we're going to make this a 24. Yeah. So this models project is going to be another library. Let's get rid of this. It's going to be another library. But all it's going to do is really it's just going to hold basically a bunch of data. There's not going to be anything complicated about this particular project other than just a bunch of data that we needed to store. And so whatever data we're going to create here, we're going to create it. We're going to build it here. We're going to pass that object over to the repository. The repository is going to run a little bit of check, and it's just going to pass it on to the data. And the same thing with the data, right? When it's going to go and create data for us, it's going to generate that data, pass it up to the repository, and then pass it up to the console application. Mm-hmm. So we're just basically sending these objects around in between projects. Does that make sense?
Yeah.
So let's go ahead and create this models project. Go ahead and share your screen. New project. And it's going to be another library. And we're going to call it significant.models. Significant.models. Perfect. And so in here, let's go ahead and rename that class and rename the file in the models. And let's call it, first of all, you know what? Let's delete this class. We want to create folders in here.
Okay.
So let's go ahead and delete this class. Yep, you're out of here. And then inside the models, go ahead and right click and add a new folder. So this folder name is going to be called requests. And then let's create another folder called responses. Lowercase e.
I don't know why I always do that.
I know my my pinky gets lazy and doesn't go that shift key fast enough to have that same problem. Okay. So when we update, we're actually sending in a request for the data to go do something for us. So you see how we need the ID, the full name, the date of birth, and the date of date and notoriety.
Yeah.
We need an object that represents that. So inside of requests, go ahead and right click and add a new class. ID, full name, date of birth. So this is going to be birth date update request. Oh, yeah, you could just put it as Pascal. You don't need underscore. Yep, that's it. Go ahead and add that puppy. So ID full name, date of birth, date of death, and notoriety. So remember, we could do the prop shortcut. So PROP, and it'll be tab. Yep. So tab again, we'll come back. Okay, no, that's right. That first one is an integer. Go ahead and tab again. And this is going to be the ID. So uppercase I, lowercase d. And then press enter. And then press enter again. You don't need the semicolon for that one. And then prop again. And then tab. And so this is going to be a string, right? And tab again. And it's going to be full name. You could just start typing. You don't have to backspace or anything. Full name. And then press enter when you're done. Come on, Jonathan. And then prop again. this is actually going to be date time. And it's going to be DOB. And then prop again. Another date time for DOD. And then a string for notoriety. Notor, like motor. Excellent. So this is, oh, you know what? We need two more changes. We need to make this a public class. And then we also need to clean up our using statements. So right click anywhere on the document and remove and sort usings. Nice. So this is it. This is literally just a data object. There's no logic. It's pretty simple. All it is just, it represents what you want to update. That's it, nothing more. It's pretty simple. So let's go ahead and save this, and then we'll go back to our birth dates. And we want to pass that object as a parameter to the update. So just like we passed the integer record ID to the delete, inside the parentheses, we want to pass that object into the update. So it's not an integer, it's an actual birth date update request.
Okay.
Lowercase p. All right. And then so hover over that. Let's fix that problem first. And way at the bottom, add a reference to significant models. So just like, hang on for a second. just like we added a reference to system.data.sql client, because somebody created a project, just like you created the models, someone created the project system.data.sql client, and you're basically grabbing a reference to their project. So you created models. Now your data needs a reference to models, just like you need a reference to the SQL client. And this is going to bring in that reference.
Executing.
Let's give it a second, see if it pulls it off. If not, I've actually haven't had too much luck with this working, which is probably a good thing, because now I can show you exactly how you're going to reference it instead of letting the magic happen. Yeah, go ahead and cancel this. It's not going to happen. I don't know why it doesn't. So let's go ahead and on your significant data project, right click on there and add a reference. Add project reference. And you're going to go ahead and click on the significant models and hit OK. So this essentially, it does the same thing as what Nuget does. It creates a reference. The only thing that Nuget does different is that it goes out to a repository, brings it locally, and then creates a reference to that project that was downloaded. And so now we have a reference, and go ahead and hover over that. And let's fix the, there you go. Now we're going to use that. So just like you did an integer on line 12, how you did integer record ID, now we're going to say our parameter is a type called that we created. You created this type called birth date update request. And let's just go ahead and call it request, or you can just REQ for short. And it doesn't have to be. Yeah, so space after.
Oh, space after.
Yeah.
So it's REQ.
Yep. All lowercase.
Requests.
That's it. Yep. So you see the difference between line 12 and line 27?
Mm-hmm.
Line 12, your record ID is specified as an integer.
Mm-hmm.
On line 27, the rec is specified as a type birth date update request. You're referencing the blueprint.
Mm-hmm.
So when .NET creates the rec in memory, it says, I need a blueprint. It's like, yeah, here's the blueprint. It's called birth date update request. And that's what that model is going to look like.
Okay.
Does that make sense?
Yeah.
Starting to come together?
Yep.
I feel it. I feel it. So on lines 45, 46, 47, 48, and 49, you're going to replace the record ID with rec.id. So go and replace record ID on 45. See how where it says record ID? You're going to replace it with rec.id because that's the property in that type that you created.
Okay.
And you're going to do it for the rest of them too.
Dot full name.
Does it make sense what you're doing?
Yeah.
Okay, cool. I think once you start creating your own types and you start passing them around, you start to understand it's like, oh, someone created an integer just like I created the birth date update request.
Mm-hmm.
So somebody had to go and create that integer. That's a type. And what you've just created a type. And the type is called birth date update request. All right.
Cool.
So again, this class is not going to interact with the user. Everything that we need is within that birth date update request. So you can get rid of lines 29 through 39. Ooh, it's a lot of code we're getting rid of. Are you nervous?
Nope. It's going to work.
Look how small that method is.
Yeah.
I mean, it's like, it's manageable, you know, it's not as complicated. Let's get rid of that empty line on line 43. We don't need empty lines. We want to make use of our space here. All right, let's go grab the next one. What is the next one that we need?
The next one is create.
Create. All right, let's grab the body of this. You'll need to grab everything from 98 to 119.
Okay.
You need to create the method first. So let's actually, I think you're missing a curly brace, right where your cursor is at. Okay, so move up to line 44 and enter a couple times. And so this is going to be a public. And for now, we'll do a void. That's fine. We'll do a void for now. This is actually going to change this time for sure. And this is going to be called create. You got it. You got the right idea. And let's just go do empty parentheses for now, and then go ahead and create the body and then paste that code in there. So let's think about this. There's two things that we're going to need. Not only do we need a request, we also need a response, because we need to receive the information, but then we also need to send back the some information.
Mm-hmm.
So there's a couple ways to do this. Let me see what would be what would be the best way to do this. I'm thinking we can probably yeah, let's go ahead and create a new request in the models. Yeah, right click in under request folder.
Oh.
Add a new class. And this one is going to be called, can you guess just by looking at the other one?
It's going to be birthday create request.
Exactly. Everything should be self-documented. You know, you shouldn't have to create some class called ABC. And everybody's like, what's ABC? It was like, well, open it up and look at the documentation in there. You know, people can look at the name of these classes and just like, oh, they're going to update the birth dates or the birth date table. Because these models pretty much represent the birth date table. Does that make sense?
Yeah.
Cool. And in here, you remember the update? It has everything we need, right? It has everything we need, but it has one too many fields, and that's the ID. Because when you create something, you don't know what the ID is.
Yeah.
You don't know what the ID is going to be. When you update something, you need to update it based on the ID. So here's what I would recommend. I would say, let's move everything from, except for the ID, let's move the other stuff from the update to the create, and then we'll have the update inherit from the create.
Okay.
Does that make sense?
Inherit.
Yeah. Remember how we created the mammal and the dog?
Okay.
So that's it. So we're gonna have it inherit everything from the create. So let's go back to the update request. Go ahead and get rid of lines 8 through 11. So it's going to inherit the full name, the date of birth, the date of death, all that. On line 5, at the end of line 5, go ahead and space colon. And then give it the name of the birthday create request. What's that red line saying?
Oops.
Oh, okay. Go look at the birthday create request. We have to make that a public class. And then so that problem goes away. So let's go back to birthday create request. So when you create a record, you don't need the ID. But when you update a record, you need everything from the create and the ID. So that's it. The update inherits from the create.
Okay.
And so it has everything. So if we go look at your birth date, class over on the left. Let's make sure nothing's broken. Yeah, look at that. Nothing's broken. Because of the inheritance model. You remember that, right?
Yeah.
So it inherits that functionality. So instead of, you see how on line 27 you have a birth date update request? On line 46, what do you think you're going to put in there as a parameter?
The birthday create requests.
Exactly. And you can call it REQ again. That's fine. And then we're going to go and update line 61 through 65, is it? 64?
Mm-hmm.
Look at that. I didn't have to tell you what you were going to update. You just knew it. You know what I wish Zoom had?
What?
A timer to tell us how long we've been on.
Yeah, they don't have that, huh?
Yeah, they don't. It would be cool to know. That way we can be conscientious to our audience.
All right.
So what do we clean up, Jonathan?
We can clean up this stuff right here.
Tell me why.
Because we're already requesting the create stuffs right here.
Sweet. Cool.
What you mean?
I think you deleted a little bit too much.
There we go.
Do a Control Z. I think you did too much. Yeah, you got rid of one too many lines.
There we go.
And then let's get rid of line 62, is it? A blank line. You can just do Control X and it'll take it out. Yep, there it goes. Man, this code is like really legible too. Like really easy to read, huh?
Yep.
All right, what's next?
Then we got display.
So the display is gonna stay here because we need it. It's the console's responsible for that.
Okay.
But we do need to get record by ID.
Okay. So we'll grab all of this.
Oh, wait. What is inside a list birthdays? Oh, okay. Yeah. Okay, cool.
So we're just getting record by ID.
Yeah, go ahead and grab that one.
Gonna make another public void. Called get record by ID, or yeah.
All right, so what do we have here? So we need to grab a record by ID. So that means that we're going to be passing in. We're going to be passing in a record ID. So this get record by ID is very similar to the delete.
Mm-hmm.
So if you look at your delete, what is your parameter on the delete?
It's a string or integer record ID.
Yeah, so that's essentially the same thing. So let's see what we got here. So we can get rid of, oh, actually this one here. Did we not copy enough? I think we're missing something. Can you go back to program? Ah, look what you missed.
Oh.
And then if you just go to the bottom and put another one.
After here. And then I fix it with,
Control KD.
there we go.
There you go. I think you're missing one more curly brace at the end. I just put it at the end.
The end.
Yeah.
Right here.
Yeah. There you go. So this one's going to receive a record ID. And I think that this one here, let me look at this first for a moment. Oh, okay. So now what we have, instead of writing, see how everything used to be at the top for the console read? We used to go and gather all the information and pass it on to the command. Now we're just grabbing a record and then we were going to output it to the console. But really what we want to do is we don't want this class to show anything to the user. So we want to create a response object that we can pass up to the console and let the console go and display the information from that object. Does that make sense?
Kind of.
So just like the console is passing in the birth date create request, and it passes in the birth date update request, the console here is just passing a record ID. And it says, hey, go get me that record. And so now that we're going to get the record, we want to be able to send back a response object, not a request object, but we want to be able to send a response object.
Okay.
And that response object has to contain ID, name, date of birth, date of death, notoriety, created at, and updated at.
Okay.
Does that make sense?
Yes.
So in the response folder in the significant.models, you're gonna create a birth date response class. And it's gonna have all those fields.
So it has to be a. How did we do it?
Oh, if we're thinking inheritance,
Mm-hmm.
can we take a shortcut here?
Oh, okay. Yeah.
We already have the create has everything. The update has the ID. So if you inherit from the update,
Oh, so I inherit the update?
yeah, because you're going to inherit everything that the create has, everything that the update has. And then all you got to do is just add the two created at and updated at.
Okay.
Does that make sense?
Yes. So just put birth date, create request.
I think it's update.
Oh, update. Okay.
Yeah. Because the update has the ID as well.
Got it.
And so the response needs to have everything that the create has, everything that the update has, and then you add the two extra fields in here.
Birth date.
All right, let's hover over that. What do we need to do? So it's interesting that within the same project, you still need to reference the namespace because it's a different namespace. So even the namespace matters in this case. And make this a public class so that everything can access it. And then all you need to do is just add those two fields, the created at and updated at. And I think they're both date time.
Okay.
It's remember prop.
Yeah. Oops. Whoops.
Press enter. There you go.
There we go.
And yeah, because it inherits everything down the line. It doesn't matter how many inheritances you have, how many levels of inheritance you have. You're going to inherit everything on that line.
Okay.
Does that make sense?
Yeah.
So here we go with inheritance. I mean, this is like a good use of it right here.
Mm-hmm.
Now, instead of receiving a record, I mean, an object, right? A custom object that you created, just like when you update and create, you're going to receive a record, but you're going to send back that response. So your return type on line 64, instead of the returning a void, you're going to return a birth date response.
Birthday response.
Yep.
Hold on. Okay.
Yeah. Cool.
And
And then, oh, okay. Well, that's because you just said that you're going to return a birthday response.
okay.
So you need to satisfy that. And we're about to do that. So instead of console writing, you're going to have to create, let's see, how do we want to do this? So we have kind of like the chicken and the egg problem here, because we need to create the object and then assign it and then return it. So remember how the variable scopes work? In order for us to be able to use a variable, it always has to be at the outermost part of the curly braces.
Okay.
So we have to create that birth date response. We have to create it after line 66. So go to 66 and press enter. And birth date response. And then I would just call the variable RESP for short for response. And then equals new birth date response. Open close parenthesis and then your semicolon. And then after line 100 or 101, I guess, return RESP semicolon. So right now, the state of your code, it's going to return a new birthday response. But what you need to do is, instead of having a console write between line 91 and 97, you need to assign those values to the birth date response object that you just created. So it'll be resp.id equals the ID. And in reality, no. In reality, we can actually get rid of lines 91 through 97, and your assignment is going to happen on 79, 80, 81, 82. So you see how you say int.id on line 79?
Mm-hmm.
See how it says int space ID? Replace the int space ID with resp.id.
Equals ID. Okay.
Yeah, it's an uppercase I. The lowercase doesn't exist. Man, I've been sitting all day. I think I'm going to stretch a little bit.
Okay. So I would do that to the same with the full name, date of birth, Date of death.
Everything.
Okay.
So if we look at line 82, right? Remember what was special about that variable that you just replaced?
Oh yeah.
It was a nullable type. So that means that on your birthday response, you have to make DOD also a nullable type. So do a Control Z to bring that code back. There you go. So you see that question mark?
Yeah.
You have to go do that in your response.
Before the dot?
No, you have to go do it in the response blueprint, in the response.
Oh.
Yes.
Got it.
Or I guess in the update, actually. Oh, sorry.
In the create.
And this makes sense, right? Because even when you create a record, you could potentially be sending in a null. You know, the data is missing because the person is not dead.
Mm-hmm.
So it makes sense to do this all the way through the create, the update, and the fetching of the record.
Oh, just like that?
Just like that, yeah.
All right.
Let's go back to the birth dates and
then I could do it.
Yep.
There it is.
Nice.
Oh, this one.
Yeah. So remember, we had to assign it to a null value. In fact, you know what? You can actually you can get rid of line 82 because by default, inside of a class, it's already a null. So you don't need to assign it as a null.
Okay.
So inside of a class, it's actually automatically a null. So yeah, get rid of line 82 and you should be good. So you also need to do 86, 87, and 88.
Oh.
Does it make sense what's going on?
Yes.
Cool.
Oops.
So you can see where you create these custom objects, and these custom objects are really just for, their responsibility is very specific. That's a create request. It's an update request. This is a response. Here's the birthday response. You're expecting some kind of response, and it's self-documented. So you don't have to worry about let me explain what this is doing. It's pretty clear what the name implies. And each one of those is so very small that you can look at it and you're like, oh, simple. It's just an object. Oh, this one inherits from this one. Got it. So it's going to accept that and these other little pieces of code. So you keep everything very small and you spread it out. It becomes a lot more understandable. Of course, you can always overdo it and just create this huge hierarchical levels of complexity, and yeah, you've gone completely haywire, and it just doesn't do any good. But here, you can pretty much guarantee that you're keeping everything nice and small. You can get rid of line 68. That's an empty line. You don't need that.
68. Oh.
And then also on line 92, it's a semicolon, not a colon.
Oh.
All right, this is looking good. What else do we got?
Then we got the list birthdays.
So this is actually creating a list. You need one more bracket.
One more. Oh.
You got too many.
What?
Yeah, if you follow the lines, right there.
Okay.
So you're listing a birth date. So instead of saying list birthday, because that method implies that I'm going to make actually list the birthdays out to the console. Here, you want to say get all. Instead of get record by ID, you're going to say get all.
Okay.
And you can just go ahead and put a void for now, and I'll show you how to fix it in a moment. We're going to get into some fancy stuff right now.
Oops.
All right. So what is it that we're building here? We're doing a while loop. And in that while loop, we are just writing out. Are we writing out to the console, or what are we doing? Yeah, we're doing console write line. We're doing a console write line, and we're writing out the ID and the full name. But the fact that this class is so far down the line that it cannot communicate with the user, we need to be able just to return a whole list of objects back up to the console and let the console application go and output it to the console. So what we're going to return is an array. And really an array in computers, what it represents, it just like when you say, I need an integer, somebody had to go and create that blueprint.
Mm-hmm.
And then you create your variable, right? So int I. And so that I gets put into memory based on the structure of the blueprint that was created in the int class. You with me so far?
Yeah.
So when you say, I need an array of integers, what happens is that it takes that blueprint and it grabs adjacent blocks of memory, literally side by side.
Mm-hmm.
That says integer number 1, integer number 2, integer number 3, and then you put in whatever number you want in that memory spot. So you can do that with strings, you can do that with floats, you can do that with decimals, and you can do that with birthday responses.
Okay.
So we can actually create an array of birthday response. And then with that array, now we can go and count the array, the elements in the array, and say, hey, get me the first element, and here, go list off to the console. And get me the next element, and go list it off to the console, so far, and so on and so forth. But there's two different types of arrays that we can, there's several, but we can either make a primitive array or we can create a list. And the reason I prefer a list is because on a list, you can always add new values. You can say, hey, go ahead and add this to the list and add this to the list. So just like a shopping list, you can just add stuff to the shopping list. The difference between the list and the array is that the list you can add, the array, you have to know how many are in there already. So if you have 100 records, you have to create an array with 100 elements. Even though they're empty, the computer is going to say, hey, I'm going to go and create this array in memory, and I'm going to pick a bunch of adjacent blocks. And the moment that you want to add an 101, it says, okay, let me get rid of this one. I got to build a whole new one. And it goes and builds a whole new one with 101 adjacent blocks.
Okay.
So if you create a list, the list will go and just put it in whatever blocks are available, but it keeps track of them for you so that you don't have to worry about creating the array. Now, as far as I understand, an array is the underlying object of a list. So internally, it handles the array for you. So it makes the job easier, okay? So on line 95, instead of a void return, we're going to return list. Oh, I'm sorry. You don't have to put return, just list.
List.
That's the return type of the method. And it's a capital L. And this list happens to be a generic type. So inside of angle brackets, so you're going to put greater than, less than. Inside those angle brackets, you're going to put birth date response. Yeah.
Okay.
And so let's get rid of that red squiggly line on the list. You need to bring in the generic namespace. System collections generic. Yep. So yeah. So this is basically, generics essentially is just a way to make the list reusable. So it's a list, but it doesn't know what until you tell it what it is. You can say, hey, I need a list of birthday response. I need a list of strings. I need a list of integers. And that's essentially what that syntax does. The method, it specifies that it's a public, means that it's accessible from anywhere. The return type, somewhere in your method, you have to return a list, even if it's an empty list, okay? Mm-hmm. So just like we created the response in the previous method, we have to create a list in our method after line 97. So you're gonna say, you need a variable, and the type is list of birthday response. And this one you can just, again, you can say response. You can call the variable response. And it's going to equal a new. And go and hit space, there it is, tab.
There it is.
And open close parenthesis, semicolon. So that's going to build a new list for you. So at the very end of the method, you're going to return the response, which is going to be the list. No, it's going to be outside of that bracket. And return the response. So we go and select all the birthdays, and the difference is that inside the while loop that starts on line 106, we need to build a new birth date response every time. So after line 107, go ahead and say birthday response. And you could just call it BR, the variable, equals new birthday response. There it is. Open close parentheses, semicolon. All right. And then just like we did on the previous method, you need to assign BRID, BR full name, BRDOB, all that.
All right.
You get rid of that line. And then just assign it on 114.
Ooh, that one wasn't that. It's notoriety. There it is.
And then go ahead and get rid of the line 120. And then let's go ahead and add another line after 118. Is it 18 or yeah, 118. And here we're going to say resp.add. Inside parentheses, you're going to put BR. So you're going to add the new birthday request. And then, so that builds your list. So you create a new birthday response, you assign all the values, and then at the very end on line 119, you add that birthday request to the list of generic birthday requests.
Got it.
And then you close your connection when you're all done.
Mm-hmm.
And at the very end, at line 124, you return that whole list.
Okay.
Does that make sense?
Yeah.
Pretty cool, huh?
I can speak computer now.
All right. Let's pause for a second.
Okay.
I'm gonna put a click on the video. And what you'll do is during the time that we're quiet and you're typing, you can actually like slice out some of the pieces, or you can separate the audio and the video and just speed up your typing, and then just leave the typing over, but just kind of shrink it into however fast,
Okay.
the speed. That way people don't have to sit there and watch you type and stuff like that. I was watching some of the previous video and I was like, oh, it's kind of painful to watch, just all that typing. So whenever you're typing out, I'll try to be quiet as much as possible so that you can just, like separate the audio and leave your typing in there, but fast, double the speed or triple the speed of the typing.
Yeah.
So that people don't have to sit there and watch you type. So, all right, I'm gonna unclick and then we'll continue. All right, so we have all the responses, and I think we're at an hour already, if I'm not mistaken.
Oh yeah.
And so I think what I want to do is I want us to pause here. You kind of get where we're going with this, right?
Mm-hmm.
It's making sense. Our methods are looking a little bit more manageable. It's not as much. I do want to do one more thing. If you compare get all with get by ID, there's some code that is being replicated there. And if we're going to live by our dry principle, which is do not repeat yourself,
Mm-hmm.
we have to create a method where we can reuse that same code, because line 79 through lines 88 is exactly like line 109 to line 118.
Yeah.
So here's what I would recommend. Go ahead and highlight 108 through 119. That's too many. You got 118. Yeah. 108 through 119 through 118. And let's go ahead and right click on here and choose quick actions and refactoring. And we're going to extract the method. And we're just going to go ahead and call it mapper because we're just mapping the results. And press enter. And so we've just taken that code and we extract it to its own method.
Okay.
So up at top, if you go to your get by ID, where is it at?
Here, right?
Yep, there it is. Get by ID. You can basically, okay, can I see the code inside of the get all?
Where?
The code inside get all. Can I see that code?
Oh.
Yeah, have it so that you can have both methods on the screen. They're small enough that you can see both of them.
Yeah.
Okay. So we could replace line 79 through 88. Just delete that. And go ahead and put a new line in there. And it's going to be RESP equals mapper, just like it is in line 99. Just pass in the reader. And then, yeah. We took the exact same code that was in both methods. We extracted it to its own method and we reused it. And look how much smaller our methods are. And you can tell exactly what they're doing. I mean, each one of these methods is about, I don't know, 10 lines of code. The ones above may be a little bit more because we're assigning some values, but they're all pretty small. And what you see here is what you would see in the industry. This is the same exact type of code that you would see in the industry. Exactly how it's formatted, exactly the small methods that you would see. This is what you see in the industry. Pretty nice, huh?
Yeah.
Yeah, that's pretty cool. So I say this is probably a good breaking point. This is a good one. I think we're gonna do a marathon's episode 10. But I think it's worth it. I think there's a lot of good stuff that we're doing here. The way we started with it, the way that we're refactoring all the code, and it's making sense. I think it's making sense to you, isn't it?
Yeah, it is.
Yeah. I mean, I don't want to create anything that you're not understanding, even though you may not remember it, but the fact that you understand it as you're doing it, you're like, oh yeah, I see what this is doing. That's what's going to just keep on, drilling not just the syntax into your head, but the fact that you'll be able to look back at this code and it's like, okay, got to keep it small, got to keep my methods, clear, concise, and we got to spread the love across the different projects so that the projects all have small and concise methods and small, objects that inherit from one another. And it's not overly complicated. Anybody should be able to open up, anybody who knows C# should be able to open up this project and look exactly what's happening. So it's pretty simple. And this is, you keep it simple and stupid. And, you're not going to have any problems with debugging, with finding bugs, fixing them, stuff like that. You just got to mess with the logic at that point. So pretty cool.
Yeah.
Yeah. I think we should wrap it up here.
Yeah.
Any final words?
Yeah. Keep it simple and don't repeat yourself. That's what I got out of this episode.
There you go. All right. I'm going to stop recording.